So, are we live now? Okay, good. Just give me 1 second. So, can you guys see my screen now? Okay, it's a bit different for me actually. So, just I will check comments. So, just tell me one more time. Okay, good. Nice. So we'll begin with, so basically the today I will talk about distributed systems and basics. So a little bit about myself. My name is Raj. I work in Amazon and I've been working for near about less than a year, but I was intern here also for 6 months, so it's combined more than 1.2 year or something. So it's a very good experience to work here, and there is a lot of learning that I have here. So I would just today try to share all my experience with you. Like I am also a recent graduate. I graduated in 2019 from IIST Shipur. Some of you may have heard it, some of you may not. But it's perfectly fine. And I was I got a 6 months intern in Amazon first in my last semester. So I was a dual degree student. That is 2014 to 2019, BTech MTech. In my last semester, I was an interning in Amazon, and at the same time, I got the PPO. Before Amazon, I was part of a AI startup in South Africa. So I've been working with them for near about 1 year, three months, or more than 1 year easily. It was a very good experience, and it was like we built the startup from the start. Like I think I was the third employee, and it went on to become a 50 plus employee company. And like we had a great fun. So it was like I haven't graduated yet, and I was already student. Also, I was working with them also, and the founder of that company was a seasonal entrepreneur. Like he had previously built a lot of AI startup. It's called Cortex Logic. Some of you can go on the internet, you can check, or maybe in my LinkedIn you can get it. So basically, today my objective is to tell you guys about the difference between working in a startup and working in a big enterprise like Amazon. And moreover, I would also get you guys an overview about how to get into these companies, Amazon, Google, Microsoft, and moreover, like what are the actual things that you do in Amazon or these kinds of companies, and how the things you study in your college, these things relate to each other. Okay. So I will just see the comments. Hello everyone. Okay, cool. So it's actually a bit weird for me to tell it. I have never done webinar like this. Like it was more inclined towards directly giving seminars, so that I could. I usually interact a lot when I talk with people. I never do a talk like this, one-way talk, but it's fine. We'll try our best. So, like one thing, when I was in my college, I was very much interested in building the things. Like it was never, I always have this thing in my mind that I don't wanted to learn small things. That I was like, if we are only learning small data structures, small algorithms, when will we build the actual things? In during my initial days, that is in first year, second year, I was more inclined towards um, learning Android development, website development, web development, and all these kinds of stuff. Rather, and I used to find data structure algorithms very boring. But obviously, for getting internships and getting the job, I have to do it. So I did. I did a good. I worked hard a lot, and I finally got opportunity to work in Amazon. So when I begin my work here in Amazon, and when it took after 2 3 months, I realized that how important the topics that I studied in my college. You will see a lot of people people I have heard they talk that the things they taught you in college, they are no useful, they are not useful, that you don't use them when you are work or somewhere. But I would try to change your perception. There are things, actually there are 70% of the things that they teach you in college are not useful, but there are things that are actually so important that if you skip them, you can't make it in the big companies, and even if you make it, you can't work there. So today, like, we'll try to understand how a distributed system works, and you will realize that it's not so difficult. Like, if you when you heard the term distributed system, there are more jargons like parallel systems and all those elastic systems, scalable systems, these kinds of things. When you heard, you think that this will be something very uh, fascinating or something very complicated, but when you see deep inside, it's not that tough. It's mostly about the basics. So little background about distributed system, the companies which make it. So it's more, when we say talk to today, when we talk about distributed system, we are mostly talking about AWS. We are mostly talking about the cloud, and three major cloud service provider. They are Google Cloud, Azure, and AWS. Obviously, AWS is the market leader. It has about 51% of share. That is more than half the market share. All the big things that you use, like Netflix, Amazon Prime, everything runs on AWS. All the big websites and all you come across internet, 50% of them, they are hosted on AWS only. So how do they manage? How do they build such a scalable system that this lasted? So let me tell you a story. Like, AWS was not the first product of Amazon, and Amazon was known for its retail business, online delivery and all, as you all know. But internally, they have built a very good infrastructure. That is, AWS was always there internally, and it was supporting the whole Amazon ecosystem. Later, they realized that they could actually finance this, and they could lend their servers to others, and then the AWS came to picture, and it was a game-changing thing for Amazon. So let me begin. Okay, so workflow orchestration. So, do you guys know about workflow orchestration? I'm not sure if you know, because when I was intern, when I heard this term, I was like, "What are you guys talking about?" So, like, when you in internet, if you search for distributed system, you would see for something like this. I will check comments one more time, and I wanted to see few things. Are you guys able to see my screen, or you guys are seeing my face? I'm not sure. Am I audible properly? Just give some comments. Okay, cool. So, where are we? So, if you look at the if online you internet you search in Google that distributed system, the kind of picture that you will get is what is this on the left. Usually they saw you with lot of systems, lot of things, lot of server images, and lot of things they show you, but actually distributed system looks more like this, what I have in my right. So what in distributed system actually comprises of multiple parts. Some of them are, as you see, the UI with which you are interacting with the server. Then they contain databases. I will come to them later, but basically they have something called load balancers, and they have something called runbooks, run and logs. So run books is basically, it's like procedure of different steps that we need to encapsulate. So don't go into too much detail. We'll explore in more in depth later. But basically, a run a workflow is this. Workflow is basically is step by step definition of a work that you need to do, and we often represent those steps as a graph. So it's usually like, you begin with step one, begin at step one, then you go to step two, then there are some decisions that you make. Based on its output, you go to step one, or you go to step three, or go to step four. It could be circular, it could be non-circular, different things happen. So if I give you a very brief example, let's say something like, a ticketing system. So in ticketing system, you have something like at one point you will book a ticket. At one point, at one step, you will place a request for booking the ticket. In one another point, you will get the ticket confirmation about it. It will show you the slots that are available. Then in the next point, you come there. You have to show the payment information. Now based on the payment information, if you pay, you go to the success page, and if you don't pay, you go to success page, and if you don't pay, you go to the previous page only. So it's these are independent steps, and independent steps we have, and based on the decisions we have, we move around different steps. So this whole process is called workflow orchestration. So this is just the first part, but basically different steps which you define them as different graph nodes, and based on the output of each step, we take certain decision, and usually we traverse through this graph via BFS or DFS search. You know this. You might know about this concept of graph called articulation point. So articulation point is a point where if I remove a particular node, the whole graph gets divided into two. So in distributed system, this has a very significant importance. Like we look for certain we look for these kinds of articulation nodes, which are like very high intensity nodes. So it's like the decision that we take there, they actually define a lot about the kind of process steps we will take. That is, if too much load gets into that articulation point, then, and if this articulation point become unavailable, then the whole graph will get divided. That is, the whole graph will be unavailable, or it will get divided into two. So special resources we add. So again, I'm getting into too much technicality. Let me go and explain it with in a very much more easier details. So I'm hoping that most of you know about procedural programming and object oriented programming. So, as previously I discussed that what we do is we do step by step difference in distributed system. We divide a total task into multiple steps, and each of the steps are a part of graph distributed system graph nodes. Now, let's say we have okay. I think I can zoom, but okay. Don't worry about these diagrams too much technicality. It's not. I will share with you guys later. But it's just to show you that this is the object oriented code, and this is the procedural code. So you know about object oriented code, right? That we have different classes. These classes interact within themselves, and data and decisions, everything is taken based on their interaction and results. So let's say the previous example that I gave, it's about a ticketing system where we have one class, let's say, which is about booking the ticket, another class which shows about the options available during the ticket, and third class which is about payment information of the ticket. Now, if you do it in this way, the basic principle of object oriented programming is what? It's about encapsulation. So if you encapsulate your classes well, so they can behave independently. That is, the uh, booking system and payment system will be totally independent of each other. They won't share, they won't interact with each other's private data. They will only interact with each other via their methods or public methods and public data. So it's very easy to convert a object-oriented program into a distributed system running program. So basically, what we do is each of those interacting classes, they becomes steps of those distributed system graph. So you can say that the booking system become part of step one. The uh, slots available class becomes part of step two, and the payment confirmation becomes step three. Payment confirmation become step four, and the outcome of each of those object become different. After of each of those object become decision. Now this is easier, so you can see that how easier it is for object oriented code to get divided into to get transformed into a distributed system code. Now let's think this about a if what if procedural programming was there, like instead of object oriented programming, if the same program we have written into object oriented, so what would have happened, that it would have been just a single file or a single class. In that class only we would have a logic of ticket booking, ticket slotting, and ticket payment information and payment confirmation. All those four classes would have been different, four different methods, and they would all have been part of a single file, a single class only, or single file as we call in procedural program. In that case it would be a very difficult for you to convert that procedural programming code into a distributed system graph, because in this way you would have to first of all identify different procedural programming program different functions that we have and all those things, and then you have to divide and write those functions into individual steps. So these kinds of things you would have to do. So you can realize that why object oriented makes it so easier, and why object oriented is so popular in modern day programming and everything. So it's like a ready made recipe. It's like in Maggie, if you just add the hot water, you get the Maggie noodles done. It's like that in object oriented programming. Basically you just have to connect with the distributed system and you have a distributed runnable code. Whereas in procedural programming it's like the raw vegetable. You have to cook it properly to get it into distributed system format. So that's why object oriented coding is so important. And it your proficiency in object oriented programming, it's not just about uh, knowing the principles of classes, their encapsulation, hierarchy, and all those. It's about like actually able to design a system. That is, I gave you this requirement about ticketing system. Your ability to design a full class diagram in how they interact with each other, their interaction, class level diagram, their encapsulation, orchestration, and their abstraction, is that this is what will make the whole all the difference. The better you can design a system in object oriented programming, the more easily it will be for that system to be transformed into a scalable distributed system code. So this is one of the importance of object oriented versus procedural. Now let me tell you that how actually we have the code, and how they interact within themselves. So when we say that different classes are going to into different nodes, so when this means that different nodes means they are running in different systems. System means computer, server, some anything. They are running in different systems, so they need a way to have a communication. That is, how will they know that payment confirmation was positive and payment was made, and those decisions that we make are based on output of one of them, but they are on different system? How do they know? When I was in my college, I used to think they must be making some API calls to each other and they must be communicating, but it's not like that. It's everything is centralized. So what they do is there are two concepts for distributed system communication, that is serialization and hash maps. So basically it's like all those between all those steps we maintain a global a class which contains it contains basically a global map, you can say. So each map will be having key comma value. So let's say payment information is a key, its value could be success, failure. So similarly, ticketing system, train ID could be key, then the value it could be 1 2 3 4 something, it could be its value. So in this way we maintain a global map, and each of the after each of those steps they update these maps values, and the next step, next node, it reads about those states via that global map. So this is basically all there about globally how how those things interact. They interact through map. Now there's also one more concept. It's called serialization. So whenever you heard the term distributed system, you should know about serialization. So because these are cross system calls, that is they are not in same systems. They may not be in what we call same country also, in same region also. They may be different places, but they have to interact. Whenever such network calls happen, you know that all of these become into stream of bytes, because the call is happening over the net. But basically what we do is there are few basic data type, that is string, int, and these kinds of things, boolean, on all those things. These three four basic things that you have, not even the hash and list. Maps and list are also not too basic thing. We have string and int. So let's say you have a complicated data structure. It could be something like a class with a different kind of data object, like a list, a map, and all these things. So what we do is we convert that class and we serialize it. Serialization is basically like converting into byte. Sometimes we encrypt it also if it is something very critical data, and and we encrypt it. And when we encrypt it, it's basically like a string. So you have a object data and you convert it into byte. With encryption it becomes string, and you transfer that string over the net, and the system which receives that data, it then converts it back into unencrypted first, and then from string, serialized string to deserialized object. So that is what distributed object. So this is how the full data that we have, the data that passes, data communication we do. Now we will we'll discuss about something which is the most important thing about distributed system, that is the scalability. So we all know that why do we do all those fancy stuff? We could have written everything in procedure, but we have to make this system scalable. And not only scalable, we have to make it flexible also. So what do I mean by flexible? So let me give you a very brief example with Amazon. So Amazon, using machine learning and all those things, or pattern recognition thing, every year they know that whenever these events like Diwali event, Amazon Prime event, Prime Day happens, all those events happen, how much expected traffic could happen based on previous year's data. So they know that during this time there will be a peak of requests. Like usually you may get about 2000 requests per second. This is the scale at which Amazon operates. Like we receive about billion requests, billion with 10 to the power 9 zeros per month, and every day it could become more than a million easily. So these many requests you get, and any increase in the rate of the request, it could be devastating. So you can't take any risk, like how we should do what we could do. So we scale up our systems, and these servers are very costly. Even though Amazon owns the AWS, it's not like you get it for free. So we try to optimize our servers. So whenever the peak ends, like Diwali, when it comes, it goes to end, we again have to quickly descale our system. So the scaling, descaling, everything has to happen very quickly. You would have It would have been very rare that you have ever find that Amazon or Google or these kinds of companies, Facebook, they ever are throwing this server unavailability error and all, because people take very good care about scalability, accessibility of the systems. So what is happening is, what do we mean by scalability? So we know that all those graph steps that I previously explained, that with that ticketing system, about booking system, payment confirmation, ticket slotting, all of them are hosted on different nodes of these graphs. And when we say nodes of the graphs, so these, that means they are totally independent. So let's say this is the payment information, payment node. In this node I can add n number of servers. So if this server is if this node is getting too many traffic, we add particular number of servers to this particular node. Similarly, in this way I can scale this node, that is the booking system, and we can add more servers in this node. So it's like we actually scale the system horizontally, that is we can add more and more servers in each of these nodes, and we can make those servers very we can make the system very reliable. And you remember I previously told about articulation point, right? So let's say this decision here that we made, that about payment information, whether the system is person have paid or not. This is like the articulation point of the graph. So this needs a special care. So more servers we need to add in this particular graph node. So these things, all this comes from algorithms, and these are the basic algorithms that you learn in your undergrad. So this will actually tell you that what's the magic behind all the scalability. Also, Amazon was the first company which actually come up with the concept of elasticity. So what do you mean by elasticity? Is elastic servers means you can scale systems up and scale them down as per your requirement. Previously, what used to happen, that people used to take subscriptions for server. So it were like 1 year subscription. So for 1 year, you would say that I would require this much number of servers. But with Amazon, it's like instance based, and you have to, you can scale them whenever you want, you can scale them down whenever you want. So this is saves a lot of money for the customers. I will give you a good example, like with recently with this corona thing. So a lot of people, they can't go out, they can't buy stuff, so they have to order from Amazon. Now nobody in the world knew that corona was going to hit us like this, and therefore nobody prepared for this. So scaling system, if it would have been so tough, like it would have been not so seamless, then it would have taken Amazon a lot of time, and Amazon would have at least be unavailable, service will show service unavailable, exception, and all those kinds of error we have thrown if system were not scaled up. But because the systems are designed in this way that we can, as soon as we know that peak is coming, request rates are increasing, we increase the servers, and the system got scaled up. And as soon as this corona thing will end, and the peak will go down, we will remove the servers and will descale our system. So this is the way the systems are optimized in big companies. Now there's another concept called load balancer. I just wanted to see one thing. Okay, so load balancer is basically like, you see, we have, let's say, three servers assigned to this particular node. All these nodes have three servers, and we have multiple requests that are coming to each of these nodes. So how do you decide that which no server will process a particular which server will actually process a particular request, and if it is to be skipped, which server to be skipped? The primary goal or aim is that you try to optimize all the servers, so that not one of them is getting to all the traffic and not and others are getting none. This shouldn't happen. So we basically use something called load balancer. And load balancer, even though it sounds very fancy, and but you will realize that it's not so difficult. I will explain some basic concepts of what basic algorithms that we use for load balancers. So there are three main algorithms. So one is round robin. That is, yeah, you go for first request to the server one, second to server two, third to server n, server three, then fourth again back to server one. That is, in this way you can process. This is a very simple but very effective way. Often in industry, is the simple algorithms have the best effect. Now, for this one, you actually have to maintain state. You know what is state? You have to know that nth number of server it is containing currently, and m number of requests. So when you have millions of requests and lot of thousands of server, then this becomes a very too big information to check. So Amazon also comes up with a solution where they reduce the cost using the randomized algorithm. Randomized algorithm is basically like, uh, by the way, this is not Amazon specific. Like it's like basic data distributed system specific. Any company can implement those things. So randomized algorithm is basically whatever request you get, you generate a random number, and using that random number, you can select the server to which your request will be processed. Even though how crazy it may sound, but this is actually at par with the round robin approach that we have. So this is something like this. These things. This is where we have implemented. Now there are also some systems which are very mission critical distributed systems. It's like divide and conquer, and in those servers we are required to So in these servers, we are required to maintain a state, as well as very high availability is required. So during this, in these kinds of systems, you know that what is the average time that a particular request will take, and you can't avoid any of them. So you have both the information. That is how each incoming request, in each incoming request, how much time it will take to process, and also what are the state of each server, that is how many requests each of the server is currently processing. So these kinds of information are there. Then we use some kind of divide and conquer technique. So there is one good problem that I found. It was actually asked in Amazon interview also. To my very surprise, this is an actual algorithm that we use in Amazon, and people have asked directly in interviews. So I will share the link in the YouTube comment, and then you guys can go through that problem. But it's basically, it's like a, what we call, it's more like a divide and conquer concept, and it's not a very critical, very difficult. It's something you will learn in your second year, first year, third year, only. So distributed, this is all the fancy stuffs in distributed system. So can you believe this is one of the most profitable business that Amazon runs today, and all the companies, be it Google, be it Microsoft, they all want just a part of the pie. The cloud business is the hottest topic going on, and I explained to you all the details of a cloud system or distributed systems that we implement, and there was nothing that I explained that is using something very critical or very difficult. This is all that you have learned in your undergrad: graphs, algorithms, object-oriented procedural programming, then data structures like hash maps, list, serialization, deserialization, and some scalability concepts. And again, then in the end, load balancer concept. Divide and conquer is a basic algorithm. Randomized algorithm you learn about in your data structure classes. Round robin algorithms and all those things. So that's the thing. That basics is the main thing that will actually take you far. Don't go behind big things that I want to build the system and all. Learn about the basics. This is what I learned when I joined the Amazon. And finally, I would like to share some thoughts about getting job in Google, Amazon, these kinds of companies. So I would just again check comments. It's a Zoom a bit. Sir, flowchart is not readable. Please Zoom. Hello, sir. Okay. Buffering. Sorry if it's buffering. But then again, I would share some thoughts about getting the interview and how to crack the interviews in Google, Amazon, and these kinds of companies. So what I have learned is there's some kind of trend that goes on for every 5 years in these companies for getting the hiring and everything done. When I was in my school, that is during 2012 or 2013-14, at that time Amazon or these kinds of companies, they used to only hire for it's for freshers. That is, for freshers they only used to do campus placement. No off campus, nothing. No concept was there. Well, the reason was they don't used to hire too many folks in India. Like requirement was not that much, so it was mostly about campus placement, and that too in top IITs and top colleges only. So this was the scenario, I think 7 to 8 years back. Then when I went to my college during my first second year, I noticed that this pattern changed. So what happened was, then these companies, they tried to extend their business in India. They have to hire a lot of people, and it's not possible to hire them all of them from IITs or NIT or top colleges. So what they did was they tried to hire on off campus, and off campus was basically done in two ways. That is, either you apply online on the company website or you get a referral. Applying online on the company website have always been just a, like, it's not this serious concept. I believe nobody I have ever met who have got an interview by applying on the online forum. But referral was a big thing. Even got I know a lot of people back then who used to get referral and get interviews on shot. So referral was like the one shot thing to get the interviews. Now recently, there again, I think from last 2 years, by the time I was graduating, I realized that there's a change in trend. The trend is good, because now the thing is there has been too many candidates that these companies are willing to interview. They may not hire so many candidates, but they want to explore all of them. Like now, companies, even still now, I believe companies do have a preference for tier 1, tier 2 colleges, certain tier 2 colleges also. But still now, that what we should say, the image or the view of companies have changed. They want to give chance to everyone. They still hire only 100 people, I think, for in a year max, but they will now try to interview at least 10,000, at least 1,000 people. Whereas earlier, if they wanted to hire 100 people, they would have interviewed, I think, sorry, they would have interviewed 1,000 people back earlier, but now they want to interview at least 10,000 people, or more than that, 50,000 maybe. So this is not possible for them to take interviews directly or via referral also. So this new trend has begun, which is like interview bit, hacker earth, hacker rank, all these kinds of stuff. Now, if it has become so popular that multiple of my colleagues and friends, I see them, they have got the job via those competitions only. That is, they competed in hacker rank or hacker earth, some competition that was organized by Amazon. Then they got the interview and then they crack it. I found to those days very few people who get jobs directly via referral. Now it's not like refer, like you will always get a interview for a referral if it is a team referral. That is, in my team, my manager or my known manager is hiring, I can refer you, and then you can get you will be sure that you can get the interview. But if there's some job ID on the Amazon portal and you want me to refer there, even though if I refer you, there's a very slim chance that you will get the referral. So this is the pattern. So I would highly encourage all of you that from your earlier years in the college only, try to practice as much as you can for competitive coding or algorithm, data structure algorithm. Be it lead code, be it code chef, whatever it is, begin with lead code always, and move go to code chef and all those things, because things have become different now. Now everybody gets a chance, so that's why things have become tougher. When I would say, I got if we in our college, Microsoft came, Amazon came, both of them came. So we were very lucky because we only have to get the interview, solve the interview questions, which are comparatively easier. But getting to that first round of online coding about that is hosted on those competitive sites, that is very competitive, I must tell you. It could be an hacker rank, it could be an interview bit, but if you solving that round, you have to be very proficient. So practice very hard, very well, and don't give it up. And never play small. Like if you are aiming for a big company, then don't settle for small. Always keep pushing yourself, keep trying, and do practice. This is a very serious thing. You can't get into those companies without practicing data structure algorithms, and you have to practice it a lot. That's all I can say. And finally, if you want, I run a blog, something called yourinterviewblog.com. You can go, I'll post the link later in the YouTube. You can go to this blog. I regularly post about on interview preparation and everything. So this thing is, I think, will be helpful with to a lot of you, because this is something I'm very passionate about. Like I like discussing with young people about how they can improve, how they can get the job in these big companies. So I write a lot about these topics. Something as this post I wrote, things I wish I knew before my interview preparation. And then I try to explain big interview questions that are very important interview questions in detail from an interviewer point of view. So I and I have seen a lot of interviews in Amazon, and I have been part of them, some of them also. So I know from the inside that how things happen there. So I believe that I have a good image, and also I'm learning, constantly learning. I always like to get in touch with algorithms. Now my area of learning is system design. I love learning about system design and machine learning too. But yeah, so this is it. I think I take a lot of time. So let me take some of the questions. So I wanted to take questions. So can you guys comment? Um, uh, So the admin guys, can you do one thing? Can you pick some questions and you guys ask me directly, and I would answer you, because reading and answering is a bit tough for me. Mm. So it's fine. Like if you later, if you have any doubts or queries, you can ask me directly on LinkedIn. I think we have the LinkedIn chat, and you can approach me, connect me, or I run this blog. You can, we have a forum section where you can comment with all your doubts. I try to address people's doubt as much as I can, but obviously I'm a working professional, so we have our limitations. And so that's it, I think. Sir, which computer, what are the main reason as to why a person could get rejected in an interview besides the fact that person might know a lot? I can give you one example. One guy I know from my college. I won't take his name, but he was very talented, and he was very good in coding, but he couldn't get a job in big companies. Big companies in the sense like Amazon, Google, these kinds of companies. So what area I have seen a lot of people, what they do is they try to spend a lot of times on competitive coding about advanced data structure, advanced algorithms, but they often try to ignore data structures and basic data structure like linked list, trees, and graphs. So when they go to actual interviews, they become overconfident that they can solve any question. But it's actually helps that if you know some types of questions before, it will actually help you. So never ignore the basics. First, you get your hands on the basics, and then you go for the advanced algorithms. So this is one thing I believe a lot of people, even though they know a lot, but they can't get selected. Second question, sir, which computer languages should we focus on in today's time? I believe Java is the best language for object-oriented programming. And once you get hired, you will be working on something similar. In Microsoft, they work on C Sharp, but that is just another way of saying Java. So focus on object-oriented programming like Java. But again, this is something if you are working on a web company like Amazon, Google, then there are companies in within Amazon also. We have something about C++. We write a lot of our machine code, infrastructure related code on C++. All our machine learning code, first they are developed on Python, then they are optimized into C++. So it's not a language specific thing, but I would suggest that if you want to learn about object oriented programming, then do Java. And if you want to get proficient about data science, then go about Python. This will be really helpful. Also, one suggestion I would give to all of you, that always focus on basics. I know that data structures are sorry, data science is something really hot now, but oftentimes undergrad people, they ignore basics of data structure and algorithms, and they skip it. So don't skip data structures and algorithms, because even if you give interviews for data scientists, first round or second round will always be about data structure and algorithms only. So you have to keep in mind that which level you are and what you need to do. Now, what's next question? Pratima Upadhyay. What do you think is more important for? Hey, she's my friend. What do you think is more important for cracking interview? Competitive coding or better grasp on data structure and algorithms? I always believe better grasp on data structure and algorithms is the first thing. Now again, I have written one blog on the same thing. You can go into my blog, where I have written that getting the interview is more tough than cracking the interview. So if you want to get the interview, if you have access to referral, then it's very easy. You no need to do competitive coding ever. But if you don't have, in that case, you can only practice data structure and algorithm. But if you don't have access to someone who can refer you, you only have access to those websites only, then go for competitive coding, because this will give you the chance to get the interview. Also, should I learn Julia? Is it good? Julia is a form of advanced Java that is designed for distributed system only. I believe you can learn it, but first focus on Java only. Just go for basics. Don't make it too complicated. Also, guys, all I would say something that I found which is most similar to how big companies code works is open source. Do a lot of open source if you can. Form your own community, start your own project. Life will be more meaningful if you do open source. Once we go, even people who get into big companies, then also they do open source. I believe open source is something that is very great. If I take an interview and someone have done something in open source, I would be appreciating it a lot, and it will surely give him a positive impact. Now, what are the main reason as to why this I completed? Sir, which company language this I designed? What are some of the challenges you have faced as an SD and also during your current tenure at Amazon? Well, this is one secret I will tell you. You know, a lot of people they say that learn from your mistakes, learn from your mistakes. It is a good proverb if you are in a small company, but when you are in a big company and you are doing a lot of critical stuff, mistakes can be very costly. So you have to be very careful and very efficient. That's why these companies, when they hire, they have such a high bar, because they can't afford that after you get hired you make too many mistakes, because they will be visible. Because if I today do something wrong in Amazon, then it will be visible to the customers. This will surely hamper the brand image. So the thing about the accuracy is a challenging, always challenging thing that we have to maintain in Amazon or any of the big companies. Now, also, should I, sir, what is your advice on research paper? How should we start with them? How much do you think our placement in companies like Amazon, Google, etc.? Well, you have to be very clear on your mind. That is, you can't. What should I say? You after from third year, before third year, I believe you should be clear that whether you want to go for higher studies or you want to get into job. Based on that only your preparation should be like that. So I believe research paper, they do have what we call some benefits of getting into big companies, but surely priorities are different. People only check your data structure algorithms and these knowledges. Even if you have some research paper published in very good conference, if you are applying for an SD role, that won't lead you much help. So be very clear about what you want. Good question, Sampath. How to work in DS algorithms for interviews? There are a lot of resources available. You just go through all those blogs. Only thing is you have to be very what we call continuous. You can't give up. You have to be doing it for a long period of time, and it will be very cakewalk. One such resource is your interviewblog.com, where I blog a lot. If I'm not from good college, what is my approach to select in top MNCs? So, like I said, lot of people I know in Amazon, in Microsoft, they are not from tier one colleges, they're not from tier two colleges even, but they got into Amazon. It's all about getting the referral, or it's about um, cracking the competitive coding. These interviews that happen on Hacker, the interview bit, these things can give you interview, and you can get the job. I will give you one example. You know, they never do campus placement these days. What they do is they have something called Google Kickstart. So a lot of people, they give interviews, thousand approx people give interviews. Out of them, I think 50 people get the interview. So these 50 people, they could be anyone based on how your coding thing. You could be from tier 4, tier 5 college, or from tier 1 college. They don't differentiate. Obviously, there's some advantage that tier 1 college always have, but you also have the option. This is what I believe. So don't uh, think that I am from this college, I can't do that, this, that. It's all about pushing hard. So I don't see any more comments. I think we should then wrap this up. So are we good? Should we wrap up or something more you want to say? Last comment I can say is sees hello. Nothing more. How can I start from scratch to crack interviews of a big companies? Always follow book. I would suggest you, there are two books, something called Narsimha Karumanchi and something called Cracking the Coding Interviews. These two books I followed. Along with that, Geeks for Geeks, Interview Bit, Lead Code, and these blogs are there. And if you want some very detailed explanation about the questions, then I am writing regularly on trying to write, not regularly, but I'm for me with my friends from Google and Microsoft and Amazon. We're trying to write post regularly on our blog so that people can actually have a better understanding. Topics which we discussed in this webinar was helpful. Thank you, sir. Thanks, Parvi. It's nice that people are appreciating. Uh, so come on, guys. I think 5 more minutes. After that, we'll go offline. Also, I would like to share one more thing. I would try to post a LinkedIn group link. I actually have one LinkedIn group which I created for people so that I could help them with the interviews and all. So I regularly try to post there. You guys can join. Thank you, sir, for the session. Was very informative and motivative. I'm glad that you guys liked it. So come on, guys. You have 4 more minutes. After that, I have few meetings also. So thank you, sir, for the session. So nobody have anything? Should we wrap this up then? Fine. I would read your thank you comments for next 4 minutes at least. So try to write something if you appreciate this session. I would really feel good. So how many people are viewing this? Can I see know that? Can any of you can type it because I don't have access to that now. Example was good to understand the thing was which you were trying to teach us. Thank you, sir. How to go approaching a technology from going 0 to 100. So about going about any technology from 0 to 100, I would say um, just keep doing. You can't do that in one day or 2 day. You have at least have to spend 3 months. So with in 3 months, if you do something, then you can do anything. But it's all about timing. It's all about patience in life. You can't. You have to be. You can't get anything in a day. It's okay then, guys. I think I will wrap this up now. It's almost 1 hour now. So I will leave this. Bye. It was a nice session. I wish I could have covered it physically. Yeah, with I could see you guys and directly interact with you. But even this one is fine. Okay then. Bye bye. Take care. Be safe. Stay inside. That's all I can say. Bye bye.